Let us talk about ground truth. This is the reliable, confirmed, and unquestionable data used to train, validate, and test AI models. Let us explore what ground truth data is, how it applies to machine learning tasks, the challenges it presents, and the strategies to ensure its accuracy. Ground truth plays a crucial role in a process known as supervised learning. Now, supervised learning is a method where we train an AI model to train tasks such as classification and regression. This approach powers technologies like image recognition, predictive analytics, and spam detection. To help the AI model learn these tasks, we provide it with labeled data, which serves as examples for the system to recognize patterns and make accurate predictions. To train an AI, we need to provide it with knowledge, which we do by using labeled data. This means we need a reliable reference, often in the form of training data. Now, that data consists of labeled examples that define what each piece of data represents. For instance, if you are using supervised learning to teach an AI to recognize cats in images, the training data would contain various pictures of cats, each correctly labeled as such. Such images might come with tags indicating different features like cat's eyes, cat's ears, or cat's tails. These labels serve as training data, helping machine learning algorithms recognize and detect similar features in new, previously unseen images. That is why it is crucial for ground truth data to be accurate. If the labels are wrong, the model won't learn the right patterns, leading to inaccurate predictions, which can have serious consequences. So, how does supervised learning utilize ground truth data? Well, let us begin with a dataset containing verified, accurate information, often referred to as ground truth data. This data plays a crucial role throughout the machine learning process. If we break it down into different phases, the first key stage is model training. During this phase, the ground truth data serves as a reference, supplying the correct answers that the model uses to learn and improve its accuracy. First, the model is trained by showing it examples such as images of a cat's eyes or ears, so it learns to recognize these features. Next comes the validation stage, where the model is tested to see how accurately it has learned from the original training data. It makes prediction, which are then compared to a separate set of known correct data. If necessary, adjustments and refinements are made to improve its accuracy. After that, the model moves into the testing phase of its development cycle. At this stage, the model is evaluated using previously unseen data. For example, we present a set of images and determine which ones contain the cats. This step is again crucial for measuring how well the model performs in real world situation. Based on these results, the model is refined and improved through an iterative process, repeating the cycle to enhance its accuracy over time. There are several supervised learning tasks that follow this life cycle, with ground truth playing a central role. Let us go over a few of them, starting with classification. In classification task, the model relies on ground truth data to assign the correct labels to each input. This process helps model categorize data into predefined groups, which can include binary categories. That essentially is a choice between two types of classification. One option is the binary classification, where the model decides between two possible outcomes like true or false. The other is multi-class classification, where the model sorts data into one of several categories. For instance, a medical AI analyzing X-ray images of an arm might classify them into one of four categories, such as broken, fractured, sprained, or healthy. That covers classification. But there is also regression. In the regression task, the model predicts continuous numerical values rather than distinct categories. The ground truth data consists of real numerical outcomes that model aims to estimate. For instance, a linear regression model can predict house prices by analyzing various factors such as square footage of the house, the number of rooms, and the location of the house. Another key concept is segmentation. Segmentation refers to tasks that involve dividing a dataset or an image into separate regions or objects. In this process, ground truth data is typically defined at the pixel level to accurately mark boundaries or specific areas within an image. For instance, in the development of self driven cars, ground truth labels help AI training models to distinguish between pedestrians, vehicles, and road signs. Now, let us examine some common challenges related to ground truth data and explore possible solutions. First, let us focus on the challenges. One key issue with ground truth data is ensuring its accuracy. I've stressed the importance of having reliable data as any errors can significantly impact the performance of AI models. For example, if a model incorrectly identifies cats due to incorrectly labeled uh, dog eyes or dog ears, that's already a problem, though a relatively minor one. But a model used in a self-driven car that was trained on flawed data, where red traffic lights were mistakenly labeled as green, would be a serious issue. But what causes poor quality ground truth data? Well, one major factor is ambiguity. Many data labeling tasks depend on human judgment, where uh, it can be subjective and it can lead to inconsistency as well. Another difficulty is complexity of the data. When information has multiple possible interpretations and depends on context, it becomes harder to establish a reliable and consistent truth. This challenge is especially evident in the fields like financial records and legal documents, where subtle nuances can significantly impact the interpretation. These concepts can become quite complex and often need specialized knowledge to label them correctly. Even if all the information in a ground truth dataset is completely accurate, it might still be misleading if the data is biased or unbalanced, resulting in a distorted representation of real world situation. Those are the difficulties we face, but what approaches can help address them? How can we create and refine high quality ground truth data? One key approach is to clearly define the goals of both your project and the AI model that will rely on this data. For example, if you are developing an AI system to recognize traffic lights across India, including regions with varying weather condition, but your dataset only contains images from sunny areas, then it may not adequately support your model's intended purpose. Another key approach is implementing an effective labeling strategy. This involves establishing clear standardized guidelines for labeling of data. A well structured labeling framework helps consistency in how different data formats are annotated, maintaining uniformity throughout the model development process. It's also crucial to ensure that the data being used is up to date, since real world information is constantly changing. Data scientists should regularly validate their models' predictions against the fresh data and adjust label datasets accordingly. Accurate labeling is the backbone of reliable AI models. Better labels result in more accurate, fair AI systems. Ultimately, maintaining high quality ground truth data is key to achieving meaningful and trustworthy AI outcomes.